Hey guys, in this video we're going to be starting our next sort of unit, if you will. It's just another portion of trigonometry. And the topic today is trig identities. So this will be something that we'll spend several days on. It's a little bit challenging, but today we're going to start with the very basics. Basically what trig identities are is they're a set of formulas, if you will, that allow us to take something like this, sine squared times cosecant, and simplify it. And the goal today is going to be to simplify these expressions into a single trig function with no denominator. So single trig function, no denominator is the goal. And to do so, we're going to utilize some formulas that we've seen before. Most notably, the secant, cosecant, and cotangent. So here's four formulas that you'll need. You're going to need, if you remember with sine, the opposite of that is cosecant. So we're going to use the fact that cosecant of theta is 1 over the sine of theta. We're going to use the fact that secant of theta is 1 over the cosine of theta. We're also going to use tangent and cotangent. So tangent of theta, if you remember, is sine over cosine. So sine theta over cosine theta. And then cotangent of theta is going to be cosine theta over sine theta. So these are very important that you know them. I would write them down right now. If you need to pause the video to do so, go ahead, write those down because we're going to use these throughout this lesson here. So basically the goal today is to we're going to sort of rewrite all expressions in terms of sine theta and cosine theta. That's going to be our first step in all of these. If we can change something into something with a sine or a cosine, that's what we're gonna do. And then we're just gonna do a variety of simplify to a single trig ratio. Now it's not always going to be super obvious how we're going to simplify it. It is always going to be possible though. You're always going to be able to simplify this into just a single trig function. It could be secant squared could be your answer, or it could be sine, or it could be cotangent, but it's going to end up being a single trig function with no denominator. All right, so I'm just going to show you some examples how to do this. Then in the next lesson tomorrow, we will add some formulas to this, and I'll explain a little bit more how exactly this is going to work. But for today, we're going to start with basics, and we're going to rewrite all expressions into sine and cosine. It's going to be our goal. So you're going to need some paper to do this. I would write down some of the examples as well, because you're going to have to do these on your own in a matter of minutes here. So first thing we're going to do, sine squared theta is already in terms of sine or cosine, so we're just going to leave that as is. And then we're going to multiply it. Now it's in terms of cosecant right now, so I want to change it to a sine or cosine. So I'm going to change it to a sine, obviously, because cosecant is equivalent to 1 over sine. So I'm going to write this as 1 over sine theta. All right, now what you'll notice is we're going to get some good cancellation here. The sine squared theta would be the same thing as writing it over 1, right? And these are diagonal from each other, so this will cancel with one of these, and we're left with just sine of theta. So that's going to be our answer. We got sine of theta. That is a single trig function with a no denominator, so we're just going to type in sine and press the little theta button, and there we go. All right, let's try another one. We'll go through a series of the multiplication ones here first. Delete some of these here. All right. So again, make sure you've written down this trig identities chart. You will definitely need that for this. All right, next one. We've got a cosecant theta times a sine theta. So obviously we need to change that cosecant. It changes into 1 over sine theta. I'm going to write in parentheses times sine theta. All right, here it's pretty obvious. Some of these will be super simple. You'll think, oh, that can't be right because it's too simple, which is the case here. These signs cancel, and we're left with just actually 1. So it's okay to have even just a single variable of 1. That's going to be our answer here. It's not necessarily a trig function, but it's just a single constant, no denominator, so we can just go with 1. Sometimes it's as simple as that. All right, let's look at maybe 1 or 2 more here. Next one, we've got 2 trig functions that we need to change into sines and cosines. Our first one is cosecant, so it's 1 over sine of theta. I'm going to write that here. And tangent is sine over cosine. So there we go. We've got it turned into sines and cosines. Should generally get a cancellation, which we do here. Those signs wipe each other out. We're left with 1 over the cosine of theta. All right, you might think, oh, we got our single trig function. Let's go ahead and type that in. However, this does have a denominator. We're not allowed to have a denominator. So what you're going to do is utilize another formula here. We know that 1 over cosine is the same thing as secant, right? So this is actually equivalent to just secant of theta. And that's going to be what we type in, secant of theta. So your answer won't always be a sine or cosine. It could be any of these as long as it is a single trig function with no denominator. That could be possibly it. All right, let's look at one more here. This one, we got a couple squared ones, which will be nice. Okay, so first step is going to be to change this into sines and cosines. Now the square doesn't really affect much other than it's just basically going to square everything. So when we have a tangent squared, that's going to be the same thing as a sine squared over a cosine squared, right? And remember, writing something like sine squared theta is the same thing as saying sine of theta quantity squared. Those are equivalent. So just how we write it with trig functions. So we're going to do sine squared theta over cosine squared theta for our tangent. And then cotangent is just the opposite. So this is going to be multiplied by, it's also squared, so it's going to be cosine squared theta on top over sine squared theta on the bottom. And what do you know? Cancel diagonally the other way. All we're left with is nothing, so it's just a 1. 1 will be our answer. So these really, to start with, are not super challenging. Once you get the hang of it, you just replace them, and generally going to get a nice, easy cancellation there that will work out for you. That's the hope. I'll just say one more. All right. Secant and a cotangent, both of them squared. All right, secant squared, well, secant is 1 over cosine, so that's going to be equivalent to 1 over cosine squared theta. We don't have to worry about the 1 squaring that because, well, 1 squared is 1 anyhow. So we're going to write that as 1 over cosine squared. And then cotangent, that's squared, so it's going to be cosine squared over sine squared. See what we get to cancel. We got cosine squareds, opposites, so we're left with, all right, this should be squared on the bottom here. And we're left with just a 1 over sine squared. Now we can't leave it because it has a denominator, but sine, 1 over sine, is the same thing as a cosecant. So we're going to change that to a cosecant squared as our final answer, cosecant squared theta. And we will type it in just like that. When you type this in, you can do CSC, and then you can do Shift 6, the caret button, squared. Make sure you hit the over button to go down, and then theta, and that should work for you to type in. All right, so that's what we're doing. Now, all of these that we've done so far have been multiplication. So I'm going to change it up just a bit here. Same idea, same strategy, except now we're going to be dividing. So these might be a bit more challenging. Same principles still apply, though. So our first question, we've got a sine theta over a tan theta. We're going to still rewrite it into sines and cosines. Sine we obviously don't need to change, but the bottom we do need to change here into sine theta over cosine theta. So we get what's called a complex fraction. With a fraction inside a fraction, we don't want to leave it that way. So this is where we keep, change, flip. Keep, change, flip. Meaning we keep the first, keep the top. I'm just going to keep that as sine of theta. We change this from division to multiplication, and we flip the bottom. So it's going to be times cosine theta over sine theta. We're multiplying, keeping the top, multiplication, then we flip the bottom. And we can also just write this sine of theta over 1, just to get a little more clear there. And then you can see we get the same diagonal cancellations like we've been getting when we multiplied. And we're left with just a cosine theta over 1, which is equivalent to just cosine theta for our first answer there. And we've got a couple more here. All right, here we go. So same strategy. We're going to replace them first. The cosine is already fine because it's a cosine. So this is cosine theta over cotangent, which is cosine theta over sine theta. And we're going to keep, change, flip. So we keep the top as cosine theta times we flip the bottom and multiply. And we're left with sine theta. Okay, so again, pretty easy once you get the hang of it. Generally the same strategy plays out. Let's see if we can get one maybe just a little bit harder here. This is a little bit different. Let's try this one. A secant and a cosecant. So we're going to replace both with sines or cosines. Secant is equivalent to 1 over cosine. So we're going to have 1 over cosine theta on top. On the bottom, cosecant is equivalent to 1 over sine, so 1 over sine theta. So we have two fractions. We're going to then keep, change, flip. Keep the top as 1 over cosine theta. Change the multiplication, and we flip the bottom. So it becomes sine theta over 1. Now here, you might think, well, we did not get a cancellation, so what's going to happen? Well, if we just multiply across, 1 times sine theta is sine theta. Cosine theta times 1 is just cosine theta. All right, now we've still got a fraction, and we still got, two functions here. Good thing is, this is equivalent to tan theta, which is a single trig function. So that is going to be our answer. Tan theta. So while no two problems are exactly the same same strategy as long as you follow that and converting them both to sines or cosines, and then we're basically just going to either cancel or keep, change, flip, something like that. You can see all these are pretty similar. Here's a squared one. Maybe I'll just take a quick look at that one first before I end this here. So squared would work the same way. We're still going to turn them into sines and cosines. A tan squared would be sine squared theta over cosine squared theta. Secant squared is going to be 1 over cosine squared. That looks pretty messy, but here we're going to have the top, keep the top, all right, change it to multiplication, flip the bottom. Cosine squared over 1 when I flip the bottom. And you can see we get a nice cancellation, and so we're just left with a sine squared theta, which would be our answer. So that about does it, and good luck with those, and I'll see you guys soon.